Hello and welcome to the last exercise in Chapter 11 on tangents and normals. Let's get into it, but before we do, let's just remind ourselves of a few things. Firstly, in the last chapter that we did, we were talking about derivatives. Remember, to find the gradient of any tangent to a curve, we need to use the derivative. So we're going to be differentiating in this particular exercise. The second thing is that a normal is perpendicular to a tangent. So the normal and the tangent are at right angles to each other, and that the gradient of a normal and a tangent will multiply together to give -1. The two gradients have a product of -1 for perpendicular lines. So let's get into our first example. Now with this particular example, what we need to know is, first of all, is that the parabola is x squared equals 12y, and at the point 6, 3, we want to find the gradient of the tangent. Now, you don't have to draw this, but x squared equals 12y would be a parabola that opens upwards. At the point 6, 3, you can draw a tangent in, and that's what we're trying to find. The gradient of that blue line, the gradient of that tangent. So, the first thing we're going to do is rearrange x squared equals 12y by dividing both sides by 12. And if we do that, we'll get y equals x squared over 12. Let's differentiate. Now remember, when we're differentiating, you differentiate the x parts. There's no x's on the bottom, so that's just going to stay there, that 12. So we're differentiating x squared. What's the derivative of x squared? 2x. So the derivative equals 2x over 12. Notice that we've got that little dash above the y. That's y prime. It's telling us it's the derivative. 2 over 12. 2 goes into 2. 2 goes into 12. So that will cancel down to x over 6. So the derivative is x over 6. All we need to know now is x values to plug into our derivative to find out what the gradient is at that x value. Now, we have a point. The point is the point 6, -3. The x value is 6. So what we're going to do is plug x equals 6 into our derivative. Now the derivative is y dash equals x over 6, so x is replaced with a 6. 6 over 6 is 1, so the derivative is 1. That means for the parabola x squared equals 12y, at the point 6, 3, the tangent has a gradient of 1. And there's the first one answered. One more example for this exercise. This one's a little bit different because it doesn't say find the gradient, it says find the equation. And the equation of the normal, not the equation of the tangent. Remember, normals and tangents are at right angles to each other. We've got our parabola, x squared equals 4y, and we're told the coordinates of the point that we're interested in. So just to draw a picture first, if we actually drew a picture of this, x squared equals 4y is a parabola that opens upwards. -4, 4 is a point on the line. We could draw a tangent in, but we're not interested in the tangent for this line. We're actually interested in what's at right angles to it. The gradient of the normal would be required, and then we need to find the equation of that green line, the equation of the normal. So that's actually what we're trying to find for this question. Well, let's go about it. So the first thing we're going to do is rearrange the parabola to allow us to differentiate, because we need to differentiate to find the derivative of the tangent, or the gradient of the tangent. So x squared equals 4y, divide both sides by 4, and you will get y equals x squared over 4. If you differentiate now, the derivative of x squared is 2x. 2 over 4 cancels, so that will give you y equals x over 2. Now we know the x value of the point that we're substituting in is -4. So in our derivative here, everywhere we see an x, we're putting in minus 4. So we get y dash, or the derivative equals minus 4 over 2, which cancels 2. Derivative is minus 2. Now what does that actually mean? That means the gradient of the tangent is minus 2. I'm not interested in the gradient of the tangent. I'm interested in the gradient of the normal. Remember our shortcut? If I know the gradient of the tangent, the gradient of the perpendicular line, which is called the normal, is minus 2 over 1 turned upside down, but the opposite sign. So it's plus a half. So the gradient of the normal becomes plus a half. Now we can find the equation of a line. We know the point that we're using. The point is the point minus 4, 4. We know the gradient is a half, gradient of the normal. So let's use the formula to find the equation of a line. Plugging in x1 and y1. There's x1, there's y1, and there's your gradient. So y take away 4 equals a half x minus minus 4, which becomes x plus 4. We get that line there. What I'm going to do now is to get rid of this half. I could times that, but I'm going to times the 2 across to the left-hand side to each component. So 2 times y is 2y, and 2 times 4 gives minus 8. So you end up with 2y take 8. I'm still left with the 1 on the top of the half. It stays on the right-hand side. It's not going to affect anything. If I times that bracket out, 1 times x is x, 1 times 4 is 4. So I end up with that. Move everything over to the right-hand side. So going to minus 2y and plus 8. The 4 plus 8 gives 12. And when I rewrite it, it could be x take 2y plus 12 equals 0. That is the equation of the normal. So we've answered the question. That's the equation of the normal to our parabola at the point minus 4, 4. Well, you're now ready to try some questions. This is the last exercise for this particular chapter. The next chapter is going to also be on quadratics, so it's on parabolas. Have fun.